Here we have another special case integration by parts example problem where we have a integral of two different functions, one that as we take derivatives it'll reduce down to zero, and the other where as we take integrals or derivatives it will constantly go into a loop, so it will never go to a unique solution. So we can still use integration by parts to solve this in the standard way by defining u's, dv's, du's, and dv's. But one method to solve this is we can use a table form. So we'll discuss this new method of solving these types of problems where we have a first function that we can reduce down to zero, and we have a second function that will loop. A lot of times, rather than e to raise to a power, you'll see this as a trig function or sine or cosine, something like that. And so you can see we'll set up our table to discuss this new method for solving. So in the differentiate column, we're going to have our u. So we'll define u as x to the fourth. And this u will be the function that we can reduce down to zero. And all we're going to do in this column is take derivatives. So we'll start with x to the fourth. We'll get the first derivative, which is 4x cubed. And we'll go all the way down until we end with zero. In the integrate function, this will be what we define as our dv. So in this case, it's e raised to the x divided by 2 dx. And we're just going to integrate each portion all the way down until we end with our last one around 0. In the sign column, we're just going to have oscillating signs. So positive, negative, all the way down, and we'll end once we get to 0. The last step is we can multiply across. So this is just a new way to do integration by parts that's a little bit quicker. So we'll just multiply down, and then as the signs change, we'll incorporate those as well. So you can see here in our solution, we have the first multiplied terms, which is positive. Then we'll have the second multiplied terms, which will be negative. And we'll do that all the way down until we get to our last term, 24 multiplied by 32e raised to the x divided by 2. You can see that here. And then we'll just do some simplification of this and we'll get our solution. So like I said earlier, we can do the standard integration by parts by defining all of our variables and writing them out, but that's very time consuming. Using the tabled approach will give us a solution that's much faster, but still does the exact same thing, integration by parts, which is what we're doing. So here is our solution.